Since the beginning of the new millennium, men and women have lived in orbit 220 miles above the Earth, traveling at a speed of 17,500 miles an hour on board the International Space Station. This complex has been undergoing its assembly since 1998 using the space shuttle, seen in this view, as well as Russian vehicles. The ISS has been for many years the largest and most complex orbital outpost in history, about twice the size and mass of the Russian space station Mir, which was decommissioned soon after the development of the International Space Station began. The ISS is composed of a series of modules and trusses that are assembled in orbit. The Canadian-built robotic arm is prominently in view. The U.S. lab Destiny, the first in a series of facility modules developed by the U.S. and its international partners, provides a docking port for the shuttle. Attached to the top of Destiny and perpendicular to the module are three segments of the truss. It provides a structural backbone in which the electrical, thermal control, and communications and navigation systems are housed. As we pass behind the truss, the U.S. node Unity comes into view. It houses additional docking ports and links the U.S. and Russian segments of the station. Attached below are two Russian vehicles named Progress, which carries supplies and fuel to the station, and a Soyuz vehicle, which carries people to orbit. It serves as an emergency rescue capsule, ready to return home with the crew members if necessary. Above is the Zarya module, or FGB, which was the first component placed into orbit in 1998. It provides storage for crew provisions and for rocket engine propellant. To the right is the main living quarters for the crew, the Russian service module Zvezda. It controls the Russian segment of the complex and contains a galley, bathroom, and sleeping quarters. At the aft end of the service module, there is another docking port for the Soyuz or Progress and for the European Automated Transfer Vehicle. Above and to either side of the cylindrical inhabited modules are large radiators which dispel excess energy into space, and solar array wings that generate more than 100 kilowatts of electrical power. As we come around the aft end of the ISS, we can see how it will look as we move toward assembly complete around 2010. Now to the aft is the European Automated Transfer Vehicle, the ATV, that will supply logistics in the future. Below is the Russian Pirs airlock. Just ahead of it, a new Russian laboratory is in view. And then ahead of it is Node 3. The last of the U.S. modules will provide housing for several new crew members and new environmental control systems that will recycle water and oxygen. On the bottom of the node is a docking port for the new crew exploration vehicle, and on the front, a room with a view, the cupola observation deck. The module covered with gold aluminized mylar insulation is the Japanese logistics carrier, the HTV, that will help to resupply the station. The HTV is berthed to Node 2, the module that connects the U.S. Destiny, European Columbus, and Japanese Kibo science labs. Now we're at the front of the ISS. Node 2 and a docking port are in the center. The European Columbus lab to the left, the Japanese Kibo lab to the right. Mounted on top of the Japanese lab is its pressurized logistics module. The Japanese facility provides an exterior platform for payloads and robotic arms for installing and moving hardware. The Canadian dexterous manipulator is above and behind the Japanese facility, mounted on the rail car of the station's mobile base, which moves up and down the length of the truss. The design, development, and assembly of the station is advancing humankind's ability to live and work in space for extended periods. As a testbed for technology development, the station is enabling the first step toward the exploration of the planets. The International Space Station serves as a model for international cooperation and is an international research center for scientists around the globe. When it is completed, this outpost will be the size of a football field, weighing 1 million pounds, housing a crew of 6. The station is still growing, gaining more capability, with a bright future as our link to the Moon, Mars, and beyond.